Hey guys, thanks for joining me. Today we're going to look at solder nuts. These are threaded inserts you put into a 3D printed hole. So pretty excited to show you this. These are the adapters we have to put onto a soldering iron in order to melt those into the plastic. So let's get to it. Okay, today we're going to do a demo of the solder nuts. These are the solder nuts that I use. I have M2, M3, M4, and M5. Today we're going to use an M5, which is these largest ones, the very largest style. So you can see there's kind of a clockwise thread and a counterclockwise thread. Those are both going to melt into the plastic. So what you do is this, I've sized that hole at, I believe it's 6.4 millimeters. And it's just big enough that it kind of friction fits in there. And I have not made it deep enough, so I have to adjust this part to make it deeper. Take a typical soldering iron, and this one has a switch and kind of a temperature control, which is convenient. Make sure that it's cool when you do this. This one's actually a little bit warm, so I'm gonna have to be careful. You basically unscrew this, and you can remove the outer shell, and then the inner shell is replaced. You replace the inner shell, and that's the heating element. So we're going to replace this inner shell, and here I've got this is my solder nut adapters. I've made a little case for them that holds all my sizes. So it has 2, 2.5, 3, 4, 5, 6, and 8. So we want the 5, that's the 5, and we'll have to use this adapter. So we take this adapter, the adapter slides right onto the heating element, and then we use the same outer shell we just removed. Put that outer shell back on, tighten this down snug, it doesn't have to be super tight, and then you can see some threads on the end. Those threads accept whichever adapter you're using for whichever nut. So this is the 5 millimeter version. So that will sneak on here. Again, the soldering iron is not on. And as we put this on the part, it just slides in and out easily, but centers up very nicely on each of these nuts. It's just basically matched to the inner dimension of those threads. So what we're going to do here is I'm going to heat it up. I'm going to go ahead and turn this on, and it's going to go ahead and heat up. And my target temperature, I think about 265. Works pretty well. So I've set 265, and here it is heating up. It's heating up. We can give it an extra minute after it's heated up. There, it should be 265. Let's give it an extra minute to stabilize at that temperature. And you can see as I heat it up, put the soldering iron there and just gentle pressure downward as it heats up. Starts to melt that plastic. And it will go ahead and drop down into that plastic. And again, this part is not quite thick enough. So I do need to design it to be thicker to catch that entire nut. And here is another. We're just going to do the same thing again. Again, this part is not quite thick enough, but we will just kind of gently place the nut into its hole. And here we will be able to kind of hold the part, gently put some pressure there. As the nut heats up, it melts the plastic and will melt down into it. And we want to go just below the surface and then stop. Maybe a 0.5 millimeter below the surface and stop right there. Again, this part is not deep enough to accept the entire nut, so I do need to design this deeper to accept the entire nut. And now the purpose of this is to be able to bolt this together. So I'm going to have a bolt coming through from this side, screwing into this, and then a bolt coming through from this side, screwing into that. So let's do that. This is an M5, metric 5 bolt that I will screw into the threads here. We'll just get it started by hand, and then we're going to take another metric 5 from the opposite direction here, and again thread it in by hand, and this whole assembly will clamp onto another device where it's going to be used. So this will actually work reasonably well, but if I build that part deeper, I'll be able to catch more of that nut. It'll be much more stable. An improvement might be to add some bolts there as well to clamp on all 4 corners. But there you can see how I can have 2 parts attach themselves, and if you snug this down, let's snug it down. Here I'm going to just snug these down, and that is a very nice, very solid. It basically locks those plastic pieces together. That's basically one piece now at this point. We're going to continue with our solder nut examples. I have some 3D printed parts here that I'm going to put some solder nuts into, so I'm going to just demo these for you. I am putting in M5 bolts, probably the 12 or the 16 depending on the situation, but M5 bolts. So I have those here, and for those I need to use the M5 sleeves, and those are the big ones back here. So let's grab a couple of those sleeves. What we'll do is we'll take our part. I kind of size these holes typically so this sleeve can just kind of snap in, and it'll kind of hang on by friction. It won't let go, and it's kind of teed up ready to go. So you can see the sleeve, there is a tiny little flat part that will just go into that hole. This one's a bit loose, but yeah, I think I can cram it in there, and so it kind of will stay there, and it just won't fall out. Even with gravity, won't fall out. And it'll be waiting for us to touch it with the soldering iron. Here I have my sleeve set that will go on. This part goes on the soldering iron. So here we've got our soldering iron. I will remove this sleeve. This is a cold soldering iron, it's not hot obviously. So we put this sleeve on the soldering iron underneath there, and then we put this cover over top, and just finger tight is pretty good. You don't have to really crank that on there too tight. And then you can see this is threaded. This takes these sleeves. So this is an 8, a 6, and a 5. So this is the 5 right here. And I 3D printed this little holder to hold these little adapters. These slide right onto the nuts. And I just kind of screw that in. And you want that snug so that the heat will transfer through there. Okay, I'm going to turn on my soldering iron here. And you'll see when I turn it on, it's got a little LCD display. So when I turn it on, it'll go ahead and start heating up. My setting on this, I think, is 280 is what I've been using lately. A little bit hotter, and it really will melt in there very nicely. So this soldering iron lets you set the temperature. So we just let that preheat for a minute, and it is set at 280. Today I'm gonna try 285. So that's the setting, and now it's heating up a little more. So let's give that a minute to heat. We'll go ahead and hook in here, and I just gently push on it and try to make sure I keep it flat. And as the heat starts transferring into the solder nut, then it starts melting that plastic, and it'll sink down through the clockwise and then the counterclockwise slant, and we want it just below the surface, and then we stop and pull back, and there it is. It's just buried in there. I still see a tiny bit above the surface, so I'm just going to actually push it slightly more. There we go. Get it just barely tucked below the surface, so it's just barely below the surface. Same thing here. Push on it, and we will try our best to actually keep it flat against the surface. And here it goes, it's melting in. Get it all the way to the surface, and a tiny bit more. And then we got to very quickly get that soldering iron out of there. Let's do a slight do a little bit more there. Okay, there we go. It's again, slightly below the surface. And there we go. We'll leave this one ready. I've got, let's see, I've got 6 more parts. We'll do a bunch of these actually. The 285 temperature works pretty good. So here we'll tee up some more. Get another part. So I'll just tuck these sleeves in with friction, and those should be ready to go. And here I'll come in with my soldering iron, and we just kind of do continuous pressure, trying to make sure, not too hard, make sure you keep it flat, just below the surface, and then quit. So I tuck that metal just below the surface. Same thing here. And once it starts heating up, it melts that plastic. And gets tucked right in there. Let me go just a hair more with that. Hair deeper with that one. And you can see there's a slight bulge of plastic there. We could certainly take a sandpaper and just, or take a little blade and slice that off. That probably has something to do with the sizing of the hole. So in this one I might, that might mean that that hole was slightly smaller on this particular part. 2 more parts. So again, we just kind of put those sleeves in there. They don't really have to line up perfectly right now. The hole itself kind of aligns them as they go, but we try not to torque too much to the side. And here we go, we're still at 285. And as it heats up, it melts in, gets going, just below the surface, and then I quit, pull out of there. Obviously, as those cool, then they incorporate into that plastic very nicely. These are very strong. They provide real good attachment points. They're very strong. And if you're doing prototypes, I've actually taken some of those and melted away the edges of the plastic and reclaimed some of these solder nuts. So if you are prototyping, you can actually reclaim those nuts, and I've used them a couple of times. The plastic gets destroyed, but the nut itself seems to break free of there pretty easily. You do have to you have to cut it and break it in half, because there's no other way to get it out of there that I can tell. I guess you could heat up a bolt and pull it out, but then you'd have a bunch of melted plastic all over it. But carving it out from the side, from both sides, seems to work pretty well. There we go, just below the surface. Just below the surface for a nice flush connection. Don't forget to turn your soldering iron off, and when we want to remove this off of here, we obviously need to let that soldering iron cool down before we can switch to a different adapter, or use some sort of needle nose pliers or something to not touch the hot sleeve. So we're going to do another one of these solder nuts. So this time I'm going to put it on here. It's going to pre-warm a bit, but it's because I can't get it to align perfectly. And then we'll put it into its position. This one, I need to make the part a slight bit deeper because that bottomed out right there. So that part needs to be a slight bit deeper. Same on the other side, I'm sure. But again, I'll put this on here so it'll kind of start pre-warming that nut. This one's going to be a little tricky to come in at an angle. And again, that part needs to be slightly deeper to accept that piece. You can see it's bulging a little behind there, which is not what I really want. And there it's bulging in to the space there. I'm trying to print faster, so these are also a little bit fuzzy. If I have sized my hole correctly, I should be able to kind of snap it into place there. And then it's ready for the soldering iron. So I am going to show you how to remove these. Let's say this was a prototype and it didn't work out. So I'm going to show you how to, I've been removing these to reuse them. So first, you can see on the back side of these that there's a little bit of space where there's no nut. So I will usually bite through with these. To see if I can at least get to the bottom of just the nut. We can kind of break apart what we can. So at least I'm to the bottom of the nut. I'm going to do that on this other one too. Kind of tear it apart. At least to the base of the insert. And we can tear these plastic off. Then we can try to bite at this and take this off. We have to be careful not to bite into the metal of the threaded insert. So that's one way. This takes a lot of effort typically. So I'm going to show you another way, but as long as we can tear this apart mechanically, now I think we can pry that loose. There we go, that's a good chunk to get off of there. Now we can pry it loose, but what we can do to help us is go ahead and thread in a bolt, and then I can pry it loose. And now we have, you can see it comes out pretty cleanly. Not a lot of residual plastic, and we'll just unscrew this. And we have a nice insert ready to use again. So I'm going to show you a different technique on removing this one. So I've got a candle here. I'm going to light the candle. And here I have an X-Acto knife. And what I'm going to do is go ahead and heat up the X-Acto knife so it's nice and hot. So that knife is getting pretty hot. Now I take that and I go ahead and use that hot knife to melt down on one side of this nut. And you can see I carved a nice little indent there. So now let's heat it up again. And now we're coming around to this opposite side. And again, we use that pretty stiff pressure down, pushing down towards the nut. And then I usually will make one more cut right through there. So let's heat it up one more time. And now we'll cut through the center. And I try to push hard and wiggle a little bit so that it'll get down to the metal. Okay, that's pretty good. Set this knife in a safe place. Okay, now that we've made one cut, two cuts, three cuts, we might be able to just screw in the bolt and snap it loose. It's not quite there, so we can help it out with this. But this will give us a good place to start biting, and it'll help those separate off. Put that screw in there. There it goes. So that took about half of it off, and you can see that's where the knife cut down. I probably needed to cut that a little deeper there. Now this, I'm going to recycle that, and then I just have to spend just a little bit of effort grabbing that and popping that off. And now again, you can see the nut comes off relatively clean there. Not much leftover plastic, and it's ready to be used again. Okay guys, thanks for watching. Don't forget to like the video, subscribe, tell your friends, and I'll see you next time.